Hello, myself Sirisha Kesara. My class ID is 14. Uh, Coming to deep learning icp2 image classification on handwritten digits. So here, what are the things that we need to do is in the source code using the history object, we need to plot the loss and the accuracy for both, and training data and validation data, and to check whether the model is overfitting or not. And for one image in the test data, we need to do the interference and check whether the prediction is correct or not, and to change the hidden layers on the source code. Going to the source code that we have, this is the source code that we have. Here we have imported the model from the Kira sequential and the dataset MNIST, which has the handwritten digits, and we are loading the data into train images and test images and its labels, and we are converting the shape of 2828 to 784 dimensional, which will be fed to the network, and we are converting the data to the float and scaling the data between 0 and 1. And here we are giving two layers, one the input layers where the shape is the shape that we have defined, and one more layer, the activation is ReLU, and the final output layer. And we are using optimizer RMS prop, and using the history object, we are using this model to fit our network, and passing the train data and train labels, and calculating the loss and accuracy using the test data and test labels, and printing the accuracy. Let me run this code. As you can see, the accuracy that we got is 98% from the source code that we have. Now the changes that we need to do is using these history objects, we need to plot the loss and accuracy. So, and also adding more layers to the module. So here is the code. Here I've added three more layers actually, with activation StanH, ReLU, sigmoid, and the output activation will be softmax. And as usual, we are converting the image shape and loading the data set, and taking the data into training and testing data, using many more layers, three more layers, and using this history object, we are calculating the accuracy and plotting that accuracy against epochs, and we are calculating the model loss and calculating that against the epochs. And also we are predicting one of the test data. The code for this is like we are predicting the 10th data in the test images, and here it is plotting to inference that whether it is predicting correct or not. Then we are doing this model.predict classes test data of 10, which gives what will be the 10th item of this test data. So it will be giving this. So by doing this inference, we can check whether it is predicting correct or not. Finally, it will give the accuracy. So let me run this code. As you see, the accuracy is 981, which only decreases some point, not 2. And the accuracy plot is this. And when you go to the loss plot is like this. And here from epoch to the test loss is more than train loss, which hence it is proof that the model is overfitting. Coming to the prediction of one of the tests, it is 0. So to check whether it is correct using you can see here the item is 0 on the 10th in the test data set, which is